Good morning, guys. It looks like everybody's signed on into my chat. The live stream is obviously still the same. I don't think we've had a lot of days where we've had both math and English next to one another, so that's how it's going to work. We'll give you a little break in between just to give me time to get set up in the studio. If you don't mind giving me a green check mark in chat so I know that everything's kind of working, you can hear me, you can see me, that would be great. And all I'm going to do is just continue on the same sheet that we were working through yesterday. We had done some pyramid questions. Now we're just going to talk a little bit about cones. And then we might get into lesson 4. I'm not sure, just see how long it takes us. So I see everybody has some check marks, which is really good. What I want to do is just jump right in and get going on these notes. There might be some people who had started the assignment from last day. If you had any questions, maybe I'll just do those at the end because there might be a few people. Yeah, see, Taylor, you went through it. It wasn't terribly difficult stuff. So if you had any questions, I'll just go through at the end because some people probably haven't looked at it yet, depending on how much time you had yesterday and things like that. So getting into the cones. So today we're going to talk a little bit about right cones, and we'll call them right circular cones. And it says, is a number D object, it's just a typo, it should say 3D object, so we'll get rid of that, turn that into 3D. So there's a picture of a cone on the side and down below. So these cones have a circular base. Guess we need to put that has a and a curved surface. So you guys have seen cones. Yeah, they're pretty common shapes. The height of the cone is this blank isn't necessary, perpendicular distance from the apex, just like our pyramids from before. That point at the very top is the apex to the base. And then we also have this slant height as well. It's the shortest distance from the curved surface between the apex down the side. And another sort of math word when we talk about circles is the last blank here. So the shortest distance around the curved surface between the apex and a point on the circumference of the base. So throwing a lot of words at you here. You can see the picture over on the side here. We have the slant height, which is the green line there. The apex, the point at the very top. We have the height, which is that line in the middle from the apex to the center of that circle. And down below, again, this stuff's all on your formula sheet, but we have some formulas here just so we can figure it out for today. The lateral area is, if you can imagine cutting this cone, you'd have the outside area. And then we have the base area, which in this case is just a circle. So there's kind of two things here. This pi rs is the lateral area, which is just a fancy way for saying the outside. Pi r squared, you probably recognize that as the area of a circle, because it's a circle on the base of this cone. So those are the things we need. One thing I will mention about pi. So we all know pi as being 3.14. And that's just an approximation for pi, 3.14. So when we are when we're dealing with pi, when you write pi down, you can either write it as pi or 3.14. Either one of those will work. But when you're doing calculations with it, you want to use the pi that's in your calculator. So most scientific calculators will have a pi button somewhere on there. And the reason that this is important is we were having some issues with rounding last day. Same thing again today. If you put 3.14, you're going to end up with the last sort of digits being a little bit off. And when you're doing like a provincial exam or even the quizzes and tests within the course, you'll notice that your last digits start to get a bit iffy. So 3.14 is a really great approximation for pi, but pi is it's an irrational number, it goes on forever and ever, and your calculator will literally store hundreds of digits of that decimal in its memory. And it's important that you use all of those digits. So Ava's asking, why is the top of a cone or a pyramid called the apex? I don't know why it's called the apex. Maybe somebody can Google it and see if they can find out. Maybe it's like a Latin thing, or I'm not sure, to be honest. What does the 3.14 key look like? Maybe I can, I'll take a little trip over to my calculator here, see if I can get this fired up. I don't know if this will run. Yeah, there we go. So I have my fancy TI-83, my big graphing calculator. You might not be able to see the pi button, but I'll just hover my little mouse over it here. If I turn it on, you can see it's right here. You can barely see. There we go. Thank you, Mr. Ross. So on this calculator, it's actually written as pi. So if I turn my calculator on, and I enter pi, in this calculator, in the window, it actually shows up as pi. I can't really get it going without moving my screen here, so anyways, you might not have it. Yeah, if you have just a plain calculator, you likely won't have it. That's why it's important that we get a scientific calculator, because these are sorts of things that the scientific calculator will have that a regular calculator won't. If you don't have a scientific calculator for right now, maybe like 3.14159, go to like 5 decimal places. That probably would be good enough for most of our calculations in the course. All calculators are different, that's the tough part. Every brand of calculator is gonna be different. The button's there somewhere if you have a scientific calculator, so it's just a matter of finding where it is. So it might not be its own button, it might be one of the secondary functions, so you might have to press shift and then find it. I'm not sure what it looks like. I'm gonna go on and do a few of these problems, so I'm just gonna scroll down here. A right cone has a base radius of 4 meters and a height of 10 meters. Calculate the surface area of the cone to the nearest square meter. So with these problems, I always find it really helpful to draw a picture. So that's what I'm gonna do. So here's my cone. I'm gonna have a circular base, and then I'm gonna have my apex up at the top. There we go. The base has a radius of 4 meters, so I'm going to draw that in. So from the middle of a circle to the edge, that is called the radius, and in this case, it's 4 meters. And the height of my my cone here, from the center down to the middle, is going to be 10 meters. Now you recall yesterday I was doing that pyramid question and I wasn't reading very carefully. After I warned you the difference between height and slant height, same sort of deal here. So hopefully I'm reading that right. A right cone has a base radius of 4 and a height of 10. It's not talking about the slant height on the edge. It's actually talking about the height from the center of the base to the center of the top, the apex. So that's the information I'm given. We need to calculate the surface area of this cone to the nearest square meter. So from up above, I know the surface area formula is going to be pi times the radius of the base times the slant height plus pi r squared, which is the area of the base. Now, what do I know? What don't I know? If you want to think about it this way, I know pi because that's in my calculator. I know the radius of the base. The one thing I don't know is the slant height, and I know the radius because it's the same thing. The radius of the base is going to give me the area of the lateral area, and the radius of the base is also going to give me the area of that base. So the only thing I need to find is my slant height. And this is kind of like what we were doing yesterday. We're using our right angle triangles, Pythagorean theorem, to calculate the slant height. So I'm going to look back at my cone image here. If I just draw on a green line here along this side, that is going to be my slant height, which is what I'm trying to figure out. I don't know what it is. And you could imagine this forming a wonderful looking right angle triangle, and I can use the Pythagorean theorem from there to calculate that. So maybe I'll just do it over here on the right, or I'll just do it down below. A squared plus b squared is equal to c squared. In this case, I don't know s, and s is my hypotenuse, so that's what I'm going to put in there. The a and the b don't matter, so I'm going to go 10 squared plus 4 squared is equal to s squared. All right, so 4 times 4 is 16, 10 times 10 is 100. That's going to give me 116 is s squared. And then I'm going to have to take the square root of both sides on that fella there. I have to write right over my pyramids here to end up with just s. So the square root of 116, again, if you don't have that scientific calculator, you're not going to have a square root button, and the rest of this is going to be really difficult for you. Plug it into my calculator, I end up with 10.77 is equal to s, or my slant height. So, looking back at the formula, we have everything we need now. We can just plug it all in and just think a little bit about our order of operations, and we should be good. So the surface area is pi. I'm just going to leave it as pi. I know the radius is given in the question. That was 4. Then I have a slant height, which I just calculated to be 10.77. Can add to that again, pi, and then the same radius again, 4 squared. Now it's just a matter of doing the math. Pi times 4 times 10.77. So, find my pi button on my calculator. So that first little bit is going to give me 135.34. I'm going to add to it pi times 4 squared, or pi times 16. It's going to give me 50.265, so 50.27. I'm going to add those together. Surface area and I end up with 185.605, so 61. All of my units in my question were given as meters, and in this case I'm finding a surface area, so I end up with meters squared. It asks to the nearest meter, so the answer that it's actually looking for is 186 meters squared, rounding to the nearest meter. So you can see that working through these problems, the cones and the pyramids are almost identical. It's just the formula for calculating the surface area is just a little bit different variables in there. But it's essentially the same thing. When we're doing a cone, we want the area of the outside and the area of the circle on the bottom. We're doing a pyramid, we're going to have 4 triangles on our faces and then some sort of shape on the bottom, whether it be a rectangle or whatever, a square, anything like that. So I'm just going to ask if anybody has any questions on that. That seems all right. I'm going to go on to the next one. And this is where things don't necessarily get tricky, but they're just kind of throwing a bit of a curveball at us. So let's see what this question looks like. A model of the Great Pyramid of Giza is constructed for a museum. The surface area of the face is 3,000 square inches. So we're dealing with units of square inches, which isn't a big deal. But just make sure when we get our solution at the end, it's going to be in square inches. The side length of the base is 50 inches. Determine the height of the model to the 1/10 of an inch. So what's different about this one is it gives us the surface area of the triangular faces, which we haven't gotten before. Normally when we do these questions, we're given like slant heights and base areas and things like that, but this is actually telling us that one of the faces has this particular surface area. So just so we're kind of clear, I'm going to draw a picture of maybe one of these pyramids. I'm pretty sure they have square bases, the pyramids of Giza, so I'll just make that assumption. Doesn't look great. Let's fix that up a bit. That's a bit better. All right, so I have my pyramid. What do I know? I know the length of the base is 50 inches, so the distance from here to here is 50, and I know one of my faces, so I'll just color it in blue. The surface area of the triangular faces, so all 4 of my faces, I should say, if you can imagine those 2 and then the 2 on the back. So the surface area of the faces is equal to 3,000. So if I had 4 faces, I could probably figure out the area of maybe one face. And from there, I can do lots of different things. So first of all, what am I trying to find? What's the question asking? So we make sure we're going to the right spot. Determine the height of the model to the 1/10 of an inch. So what we are physically trying to find is the distance from the apex down to the middle of the base. We're trying to find that h. All right, so we know the area of a face, we know the length of the base. We're trying to find the height of this model here that somebody's made. Anybody think of a way that we could maybe get that height from some of the information that we have? You're gonna kind of see a bit of a trend. You're always gonna end up using the sort of same processes to get these things. Nobody's chiming in real quick, so I'll just maybe continue on. You can imagine I draw a little dotted line out here to the edge. Of course it's the Pythagorean theorem, Abby, yeah. I can draw a triangle here within the inside of this. So on this side face with the green line, I've drawn a triangle. So what I'm going to do is, let's think about it this way. The surface area of 4 faces, maybe I put a 4 in here, is 3,000. What would be the surface area of one face? But in this case, just 1. All I'm going to do is take this 3,000 and I'm going to divide it by 4 because I have 4 faces. So to figure out the surface area of one face, 3,000 divided by 4, you can end up with 750 inches squared for one face. So what I'm going to do is just redraw one of these faces, and you can maybe get an idea of where I'm going. So here's my face. I know the area of the face is 750 inches squared. I know the base length of a face is going to be 50 from the picture above. And that was given right in that question. So if I could figure out the height of this triangle, that would give me the green line on my other image here, and then from there I could figure out the red line. So we're kind of working our way backwards. So I also know that the area of a triangle is base times height divided by 2. I was given the area of 750, kind of roundabout found that. The base is 50, that was also given in the question. I don't know what the height is, but I can plug all these numbers in, and then it's just algebra to get that h by itself. So I have this 2 on the bottom. The opposite of dividing by 2 is multiplying both sides by 2. So I'm going to do that. So my 2's are going to cancel. End up with 750 times 2 is 1500, is 50 times the height. And then I'm going to divide both sides by 50 to end up with just my height. So 1500 divided by 50 is going to give me 30. So 30 is equal to the height of that face. Or the slant height. So I'm going to just scroll back up here to my image. I'm trying to find the red line. What I just found was this green line here has a length of 30. The blue line that I've drawn in here, this dotted blue line, I'll make solid now. If the whole distance across the whole face is 50, if I only go halfway, I know that that is going to be 25. So maybe I'll just redraw this triangle over on the side here. So I'm trying to find the red line, H. That's what I'm looking for. I just found out that the face, the slant height, was 30 inches. And I know from my diagram here that the blue base is 25. So again, just a Pythagorean theorem question for the second time to figure out what that h is. So write down my Pythagorean theorem, a squared plus b squared is c squared. In this case, c has to be the 30. The h is what I'm trying to find, so h squared. Go with the 25 squared on the bottom. And that's equal to 30 squared. So I'll do my exponents, and then I will solve for h. So 25 times 25 is 625. 30 times 30 is 900. I'm going to subtract 625 from both sides to end up with h squared by itself. 900 minus 625 is going to be 275. And then I'm going to take the square root of both sides. Because I had h squared, I just want h. So h is going to be equal to the square root of 275. When I plug it into my calculator, gives me 16.6. And the question did ask for the nearest tenth of an inch. So I've gone to the tenths with the 16.6. Last thing I'm going to do is say, does this answer make sense? And if I go back and look at my diagram, I have the base was 50 inches across, the green line was 30. So that's 16 for the red line, the H. It kind of makes sense. It's not terribly far off. So I'm happy with that. It's within the same sort of ballpark as all the other numbers that were given in the question. So again, that one was tricky because we're kind of working our way backwards. We've been given the area of a face. It was the area of the four faces. So we needed to spend a little bit of time thinking about what we were actually given, how we could go about solving it. So you'll notice that a lot of the problems that we'll see kind of look a bit like this. They're usually using the Pythagorean theorem at least once, maybe twice, to find a side of a triangle, using that information to figure out a part of a formula. Sometimes they'll give you the surface area and you work backwards. Sometimes you'll be given the information, you work towards the surface area. But the important thing is you're able to plug the numbers into the correct spots in the formula and figure out what you're actually trying to find, what variable you're trying to identify in the question. So that is surface area of cones and pyramids. So right cones, right pyramids. I want to just have a quick look at the next lesson, which is lesson 4. I didn't know if I'd make it this far or not today, but it looks like I will. And maybe I can get a couple of those done just so we can move on, keep cruising through. So that's the end of lesson 3. The lesson 3 practice is there, and you'll notice the lesson 3 practice is pretty straightforward. It doesn't have a ton of really hard questions on it. There's even some nice introductory type shapes at the beginning to kind of, get you used to dealing with the areas of just basic shapes like triangles and squares and rectangles and things like that. So this is what the lesson 3 practice looks like. The pretty basic stuff at the beginning: open top box, rectangle. This type of question here, you're just dealing with a triangle, and then you have a rectangle here, and then you have a rectangle on the bottom that you can't see, and a rectangle on the back. So you guys have seen questions like these before. Composite shapes, so you gotta get your saw out and cut this off. So you have a rectangular prism, and then you have 2 triangles on the ends to deal with. Again, same sort of thing on the top and the bottom. You have some triangles, rectangles. So essentially it's just adding up all of those things. If you wanted to ask some questions about the practice now, I would be happy to go through them. I know some of the shapes are a bit strange. Maybe before we jump into the lesson 4, you could fire away a few questions here. There is a cylinder here, so make sure we go back to our formula sheet to look at the cylinder formulas. So then you kind of get into the right pyramids that we dealt with last day. Another right pyramid, some cone stuff, and then there's some problems. Ava's asking about 2B, for sure I can go into that. While you guys are writing in maybe a few questions, I want to mention one thing about number 4 here. Is this you see this 90 pi. 90 pi. So determine the height of the right circular cylinder with a radius of 3 feet and the surface area was 90 pi. Don't be confused by 90 and the pi being together. Essentially, if you plugged into your calculator 90 and multiplied it by the pi, it's going to give you something like 280, I don't know exactly what it is, just guessing there. That's all it's saying. So it's just basically there's sort of two ways that you can write the answers. An exact way with pi in it, so not doing the multiplication but with the pi, and then you could write it as a decimal. So sometimes it'll ask for an exact answer with the pi left in, just basically you don't have to do the multiplication. Sometimes you'll see it as a decimal. So I know some of the answers are kind of written a little bit goofy looking with these radicals in here. So these are just exact answers, and basically if you get that far, you can plug it into your calculator, like square root of, the first one here was the square root of 10, or this one, the square root of 73. You can just do the actual radical, and then you'd be okay. So we're going to talk a little bit about going back and forth between mixed radicals and things like that in the next unit. So don't worry too much about these types of things. The question was 2b and c and 4, and I think that's coming down to the exact answers. 2b and c, and then 4. And then just the answers are in exact values. Is that what I'm gathering? Yes. And 4, height of cylinder is 12. Okay. How about I do this for you guys? If we lose the exact value thing for now, because we haven't dealt with that yet. So the square root of 10, multiply that by 16 and add 16 to it. So this answer here should be 66.596 meters squared for 2b. And then the other one here, it's going to be the square root of 5 times 24. Let's write this down, 53.66. Square root of 73 times 8 plus 53.66 plus 48. And this one should be 170 yards squared. So hopefully that kind of alleviates those problems. Again, it's just something we haven't gone through yet. I kind of mixed up the order of the units I like to do. So Abby, does that help, or does that make you a little bit more confused? I think that's probably a little bit more helpful. All right. Perfect. I'm just gonna leave that practice for now. A lot of people haven't probably had a chance to go through it. I'm gonna just jump to lesson number 4 because it's kind of the same, but it's actually a little bit easier than the stuff we've been doing. And maybe you can just get a few parts of this done. It's only like 4 questions, so I'm hoping maybe 20 minutes I can fly through this. So let's just jump right in. You have just seen with class sand example. So what I did in class, I had these big 3D shapes and we could pour the sand, and you guys haven't seen that, but you can imagine it. So the volume of a right prism is 3 times the volume of a right pyramid. With the same base and the same height. So when I was teaching this course at, I guess it was OCAM the last time I taught it, I had these really cool, big 3-dimensional shapes. So you can see what I'm talking about here is this shape and this shape. Basically the volume, so if you imagine when we're talking about volume, it'd be like filling it up with water or sand or something. That's the volume, how much stuff goes in the inside. Remember, the surface area is the outside. If you were to maybe like paint it, what's the surface area? The volume is filling it up. So the 2 shapes we have here, this is a right prism up top here, and this is a right pyramid. It works out that the volume of the right pyramid down below here is 1/3 the volume of this guy. So you can fit the volume of 3 of these into the same base shape. So that's kind of where this stuff is coming from. And just to give you an idea of where these formulas come from that we're given, the volume is the area times the area of the base times the height, and here it is 1/3 the area of the base times the height. So I think volume's easier, and generally students will agree with me. Let's look at number 1. Calculate the volume of this right square pyramid to the nearest cubic foot. So to determine the volume, I'm going to need to write down my formula. 1/3 area of the base, I'll write in base here just to remind us, times the height. As you can expect, for all of these problems, it's never just going to be a matter of looking at the problem and plugging the numbers in. There's always going to be like 1 or 2, or at least 2 steps, never 1 step, always more than 1 step. So the image that we've been given, we have some numbers drawn in here. It's showing us 7, and it's important to note that that 7 is, if I follow the dotted line here, the 7 is the slant height, and what we're trying to find is the height down to the middle of the base. It's kind of difficult how it's written there. So, same as we've done many, many times, the length of the entire side here is 2, so this is 2 by 2. So if I wanted to just figure out what one little part of these would each be 1 foot, because it's divided in half. So I have 2 sort of 1 foot sections. So we're trying to find the red line, the height, in order to plug that into our formula here. So without the height, we don't have anything. We can figure out the area of the base is just a square, so it's going to be 2 times 2, or just 4. But we need to find this height. So what I'm going to do is, like always, I'm going to take this square base pyramid, and I'm going to cut it down the middle, and I'm going to end up with a triangle. So that is my height, which I'm trying to find. I have this blue line along the bottom here. I'll draw it out that way. I know that that's 1 foot long, and then I have my slant height, which is given in the problem as 7 feet. So same process as before. Use the Pythagorean theorem. I'm going to maybe just go a little bit faster on this one because you guys have seen this before. A squared plus b squared is c squared. The c has to be the longest side. So I'm going to go h squared. That's what I'm trying to find, so I can plug that in up above. Once I've found the height, I'm good to go, but for now I don't have it. H squared plus 1 squared is equal to, my longest side is 7 squared. 1 squared is going to give me 1. And then 7 squared is going to give me 49. So h squared plus 1 is equal to 49. I'm going to subtract 1 from both sides to get the h by itself. So I'm going to get h squared is equal to 48. And I need to take the square root of both sides to give me h is equal to the square root of 48. And I'll actually calculate the square root of 48 and just put it down as a decimal. So that's going to give me 6.93. All right. Now I know the height. If I think about the base of this pyramid, this is just 2 times 2, so the area of the base is just going to be 4. Haley's ahead of me. 6.93, she's got it. I'm just going to plug some numbers into my formula here. So the volume, because it's asking for the volume to the nearest cubic foot, is 1/3. Area of the base is, I'll write it as 2 times 2. And then the height I just calculated to be 6.93. That 2 times 2 is a bit confusing. 1/3 times 4 times 6.93. In my calculator, I still have that 6.93 in my window, so I'm going to multiply by 4. And then I'm going to hit equals, and then I'm going to take that, it's 27.7, and then divide it by 3. So I'm going to kind of work my way backwards across the formula. I end up with 9.23. Try to remember my units. Everything in the question is in feet. And it's a volume, so hopefully you recall that volumes are cubed, so feet cubed. As for the nearest foot, so in this case, it's just simple 9 feet cubed. So that's kind of the process here. Same thing, similar process as the surface area. Usually the calculations here are a little bit simpler. It's all multiplication, so we don't have to worry about adding things together. Just kind of, students generally find these volume questions a little bit easier. It looks like I maybe have time for one more. And that should give you guys a good jump on this lesson 4 over the weekend. Number 2, determine the volume of a right rectangular. Abby's asking about multiplying by 0.333 instead of dividing by 3. Remember, if you go 1 divided by 3 in your calculator, it's going to give you 0.33333, and that's an irrational number. It's just going to, it's a rational number, but it's going to keep going forever. So by using just 0.33, you're approximating it, so you're going to end up with kind of that same sort of rounding stuff that we ran into last time. So get into the habit of just dividing it by 3, and that will give us a more accurate answer, so we'll have less issues. Divide by 3 or multiply. If you wanted to go times 0.33333 and just hammer on that 3 a bunch of times, maybe like 8 or 9 times, you're going to end up with the right answer. But it's just, you're making an approximation. We want to kind of trust our calculator. It's carrying lots and lots of digits, usually 8 or more in its memory, and we're going to use that to our advantage. So when we get to the end, we're not dealing with sort of rounding errors. We're on the money all the time. So the next question here, determine the volume of a right rectangular pyramid with a base that's 3.6 by 4.7 and a height that's 6.9. This is kind of one of these rare examples where I think we're given everything we need. So I'm going to write down the volume. So this, again, off of our formula sheet, a right rectangular pyramid, it's going to be the area of the base. I'll write A with a little sub B times the height. And then I look at what I have in my question here. I have the base is 3.6 by 4.7. I have a height of 6.9. So literally, I don't need to find anything. I don't need to use the Pythagorean theorem. It's kind of everything's given to me. You don't really even need to draw this picture. I'm going to draw it just because I like to make sure I'm understanding things properly. There we go. So it says this is the 4.7, this is 3.6. I'm given an actual height, not a slant height, but a height to the middle there of 6.9. So I have everything I need. It's like a gift. So 1/3, area of the base. The base is a rectangle, so I could just think of that as length times width. So 4.7 times 3.6. And then I'm going to multiply that all by the height of 6.9. So 3.6 times 4.7 times 6.9. I'm going to leave the dividing by 3 to the end as I enter it in my calculator. It's just kind of how it makes sense to me. So what I'm physically doing is 4.7 times 3.6 times 6.9. And I'm going to hit the equal sign on my calculator, and then the answer is going to be displayed there. And then once I've done that, I'll use that divided by 3 at the very end. And then I get 38.9. And the answer to the nearest tenth of a cubic meter, so 38.91, so it's just going to be 38.9 meters cubed as my final answer. So I want to respect your guys' time and not take any more of it, but the cones, the pyramid stuff we just did, it's there. You can see there's a couple of cylinder and cone formulas here, and those are exactly the same as what we've been doing. So what I'm going to say for today, and to maybe catch up on a bit of time, and I'm confident that you guys will be able to do these cylinder and cones, is I'm not going to go through these last 2 problems. I will, however, throw the answers down. So if you want to go through them, I have them actually done here. So number 3 was 218 millimeters cubed was the answer for 3. If you want to just jot that down. If you want to try that, you're welcome to. I won't do it next class. Number 4 is tricky, but the answer is 6 meters for the radius. So that one's a working backwards one. So for now, I'm going to leave it. I'm going to trust that you guys are going to be able to do those last 2 using the formulas there. The last one's kind of working backwards. You're given the volume. You have to find the radius instead of the radius to the volume. What I would like you to do, because you guys have Friday, hopefully you're going to come bowling tomorrow, which would be awesome. You guys have Friday and then the weekend. I'd like it very much if you guys could get done the practice for 3, which hopefully you had a chance to do a little bit of already, and the practice for lesson 4. So essentially I've done 3 and 4. And that leaves 2 more for next week, and then we'll have our unit exam next week as well on this beginning stuff. So that's it for me for today. Hopefully I'll see you guys bowling tomorrow. I'm not sure if I'm even invited. I'll have to ask Mrs. Wood. Hopefully I got invited. If you could do 3 and 4, and then I think lesson 4 has a quiz at the end of it. So if you want to give that a go, that would be great. I totally understand if you want to wait till Monday's class to give me a chance to go over practice 3 and 4 if you had any questions, and then try that quiz there. Next week, what's it looking like? We're not going to see you on Monday. Mr. Ross is Johnny on the spot here. It looks like we don't see each other until Tuesday next week. So maybe I'll tell you what, for the 3rd quiz after lesson 4, what I'll do is I'll give you 3 attempts at it instead of the normal 2. So if you want to try it, you do well, awesome. If not, you can wait for me to go over this stuff on Tuesday's class, and then you can have another attempt. I just want to make sure we're kind of keep moving. I don't want to fall too far behind. So again, lesson 3 and 4 are now done. Have a go at the quiz. If you have any questions about the practice on 3 and 4, I'll go over that on class on Tuesday. And that's it. So hopefully we see you guys tomorrow, and have a great weekend.